Chapter 6 NAT for IPv4. In this chapter, we are going to cover following sessions: 6.0 Introduction, 6.1 NAT Characteristics, 6.2 The Types of NAT, 6.3 The NAT Advantages and Disadvantages, 6.4 The Static NAT, 6.5 The Dynamic NAT, 6.6 The PAT, and then 6.7 NAT 64. Without further ado, let's start. Let's start with 6.1, the NAT characteristics. As you know, the IPv4 addresses are very limited. There are simply not enough public IPv4 addresses to assign a unique public address to every computer, smartphone, printer, and also the IoT devices connected to internet. To solve the problem, most organizations and home networks use the private IPv4 addresses. Private IP address range are defined in the RFC 1918. Devices using private addresses can communicate within a local network, but they cannot communicate directly over the internet. To access internet, their private addresses must be translated into the public addresses using the network address translation called NAT. The RFC 1918 private address ranges. The RFC 1918 defines three private IPv4 address ranges. Class A, private range. The first range is between 10.0.0.0 through 10.255.255.255. The prefix 10.0.0.0/8. This is the largest private address block, providing over 16 million addresses. It's commonly used by large enterprises, universities, and government organizations. Now let's move to Class B, the Class B private range. The second range is between 172.16.0.0 through 172.31.255.255. The prefix is 172.16.0.0/12. Notice that the only addresses from 172.16 through 172.31 are private. The addresses such as 172.15.x.x or 172.32.x.x are not private. This range is commonly used by the medium-sized organizations. And then we have the Class C private range. The third range is from 192.168.0.0 through 192.168.255.255. The prefix is 192.168.0.0/16. This is the range most people recognize because it's commonly used in home and small office networks. Many home routers assign the addresses such as 192.168.0.x or 162.168.1.x using the DHCP. As we learned, private IPv4 addresses are used inside homes, schools, and organizations for local communication. Devices with private addresses can communicate with each devices with the same local network without any problem. For example, a computer with the address 192.168.1.10 can communicate with a printer at 192.168.1.20 because both devices are on the same private network. Private address cannot be routed on internet. However, private IPv4 addresses have one important limitation. They cannot be routed over the public internet. Why? because private address ranges are not globally unique. For example, millions of homes around the world use the network 192.168.1.0/24. If internet routers try to route private addresses, they will have no way to determine which 192.168.1.10 you are trying to reach. For this reason, the Internet Service Provider, the ISPs, and the Internet routers do not forward private IPv4 addresses. As shown in the figure, the network address translation, the NAT, translated private IPv4 addresses into the public IPv4 addresses. These allow devices on a private network to communicate with resources on the Internet. Without NAT, devices using private IP addresses would not be able to access the Internet because private addresses are not routable on the public Internet. And now let's talk about how NAT works. The NAT router sits between the private network and the public Internet. When a device sends traffic to the Internet, the packet leaves the device with a private IP address. The NAT router replaces the private source address with its public address. The packet is forwarded across the Internet. When the reply returns, the NAT router translates the public address back to the original private address. The packet is delivered to the correct device in the network. This translation happens automatically and is transparent to the user. Without NAT, the exhaustion of the IPv4 address space would have occurred well before the year 2000. However, NAT has limitations and many disadvantages, which will be explored later in this module. The solution to the exhaustion of IPv4 address space and the limitation of NAT is the eventual transition to IPv6. NAT has many uses, but the primary use is to conserve the public IPv4 addresses. NAT-enabled routers can be configured with one or more valid public IPv4 addresses. These public addresses are known as the NAT pool. When an internal device sends traffic out of the network, the NAT-enabled router translates the internal IPv4 address of the device to a public address from the NAT pool. To outside devices, all traffic entering and exiting the network appears to have a public IPv4 address from the provided pool of the addresses. As shown in the figure, a NAT router is typically placed at the edge or the border of a private network. This router connects to the organization's private network to the public Internet. Because it sits between the two networks, it is also called a border router. When a device inside the stub network wants to communicate with a device outside the network, the packet is forwarded to the border router. The border router performs the NAT process, translating the internal private address of the device to a public, outside routable address. Note, the connection to the ISP may use a private address or a public address that's shared among customers. For the purpose of this module, a public address is shown. Let's walk through a simple example of how network address translation works. In this example, PC1 has a IP address 192.168.10.10. The destination is the web server on the Internet with a public IP address 209.165.201.1. Our goal is to see how PC1 communicates with a public server, even though it has a private IP address. Step 1. PC1 create a packet. PC1 wants to access the web server. it creates a packet with the source IP of 192.168.10.10, and the destination IP is 209.165.201.1. Since the destination is outside the local network, PC1 sends the packets to the default gateway, the border router. Step 2, the border router performs NAT. When the packet reaches the border router, the router recognizes that the source address is a private IPv4 address. Before forwarding the packets to the internet, the router performs the network address translation. It replaced the source address 192.168.10.10 with its public IP address. Records the translation in the NAT translation table. Now the packet is ready to travel across the internet. Step 3. Packet travels across the internet. The packet is forwarded through the ISP to the destination server. The web server receives the packet and sees the source IP, the router's public IP address, also the destination IP 209.165.201.1. Notice that the server never sees PC1's private IP address. Step 4. The server sends a reply. The web server sends a response back to the router public IP address. The reply travels through the internet and reaches the border router. Step 5. The NAT translates the address back. The border router checks the NAT translation table. It finds the matching entry and translates the destination address back to the 192.168.10.10. The router then forwards the packets to PC1. PC1 receives the response, and the communication is complete. So, as a summary, this is the overall process. The communication follows these steps. PC1 creates the packet using the private IP address. The border router performs NAT. The packet travels across internet using the router's public IP address. The server replies to the public address. The router translates the destination back to the private address. The reply is delivered to PC1. To both PC1 and the server, the communication appears seamlessly because NAT performs the address translation automatically. In NAT terminology, the inside network is a set of networks that is subject to translation. The outside network refers to all other networks. When using NAT, IPv4 addresses have different destinations based on whether they are on a private network or on the public network, such as Internet, and whether the traffic is incoming or outgoing. The NAT includes 4 types of addresses: the inside local address, inside the global address, outside local address, and also the outside global address. When determining which type of address is used, it is important to remember that the NAT terminology is always applied from the perspective the device with the translated address. Inside address, that is the address of the device which is being translated by NAT. And for the outside address is the address of the destination device. NAT also uses the concept of local and global with respect to the addresses. The first one is the local address. A local address is any address that appears on the inside portion of the network. And then there is a global address. For global address is any address that appears on the outside portion of the network. The terms inside and outside are combined with the term local and global to refer to specific addresses. The NAT router R2 in the figure is the demarcation point between the inside and the outside network. R2 is configured with a pool of public addresses to assign to inside hosts. Refer to the network and the NAT table in the figure for the following discussion of each of the NAT address types. The address of the source as seen from the inside of the network. This is typically a private IP address. In the figure, IPv4 address 192.168.10.10 is assigned to PC1. This is the inside local address for PC1. The address of the source is seen from the outside of the network. This is typically a global routable IPv4 address. In the figure, when the traffic from PC1 is sent to the web server at 209.165.201.1, R2 translates the inside local address to an inside global address. In this case, R2 changes the IPv4 source address from 192.168.10.10 to 209.165.200.226. In NAT terminology, the inside local address of 192.168.10.10 is translated to the inside global address of 209.165.200.226. The address of the destination is seen from the outside network. It is a global routable IPv4 address assigned to a host on the Internet. For example, the web server is reachable at IPv4 address 209.165.201.1. Most often, the outside local and outside global addresses are the same. The address of the destination is seen from the inside network. In this example, PC1 sends the traffic to the web server at IPv4 address 209.165.201.1. Well, uncommon, this address could be different than the globally routable address of the destination. PC1 has an inside local address of 192.168.10.10. From the perspective of PC1, the web server has an outside address of 209.165.201.1. When the packets are sent from PC1 to the global address of the web server, the inside local address of PC1 is translated to 209.165.200.226. Inside the global address, the address of the outside device is not typically translated because that address is usually a public IPv4 address. Notice that PC1 has different local and global addresses, whereas the web server has the same public IPv4 address for both. From the perspective of the web server, traffic originating from PC1 appears to have come from 209.165.200.226, the inside global address.